Alright, so we're going to now look at Unit 2, which is solving linear systems. So the first section is 1.1, modeling and graphing lines, and we're going to do a little bit of review from last year. So first, when you want to find a point of intersection, the first thing you have to remember is that you're finding the point where two lines cross. Okay? So first you must have the equations as mathematical form. Remember the difference between an expression and an equation is the equal sign. So if you don't have an equal sign, you've only written an expression. So in grade 9, we translated words into expressions and equations using math language: double, sum, times, is, product, and so on. And we found the point of intersection by graphing the two lines and seeing where they crossed. So think back, which type of lines never intersect? Okay, so if you think about lines that will never intersect, they're lines that are parallel. What type of lines always intersect? Lines that are sitting on top of each other always intersect. So remember, when using graphing to find the point of intersection, we need to use graph paper, grid paper, to be accurate. So first let's go back and practice translating each phrase. So 2 more than 6. How would we write that? Right, so you should have 2 plus 6, 2 more than 6. You could also write that as 6 plus 2. Next, 2 more than a number is 6. So 2 more than a number is 6. Because we have the equal sign and the word is, this now becomes equations. So you can either write it as 2 plus x equals 6, or you could write it as x plus 2 equals 6. And finally, triple a number is half the difference of the same number decreased by 5. So break it down. Triple a number is, so now you're going to have the equal sign, half the difference, so now we're going to be subtracting, so half the difference, you can either write that as 0.5 times, or you can put in brackets the part that's remaining and then divide it by 2. The same number, so the variable that you used on the other side, decreased by 5. Okay, so notice we put x minus 5. So again, you can put 0.5 times that in brackets, or after the brackets you could say divided by 2. Alright, so now let's try graphing. Find the point of intersection by graphing. So first we're going to graph the line y equals 4x minus 5. So remember, to graph that, we're starting down at negative 5 and we're moving a slope of 4. So up 4, right 1. Up 4, right 1. So notice we come down to 4, it's down to a negative 5, and we've gone up 4, right 1. Up 4, right 1. Next we have the line 2/3 x plus 5. So we're going to go up to 5, and then we're going to go up 2, right 3. Up 2, right 3. So up 2, right 3. Up 2, right 3. We can look at this graph and we can clearly see that this is our point of intersection. It's where our two lines cross. So our point of intersection is at the coordinate point 3, 7. So now we're going to start looking at some word problems. When creating equations for word problems, you must include a let statement defining your variables. Okay, so if it's not clear what your variables are because it's an x or a y or numbers, then you need to include let statements defining your variables. So, last example, example 3. JJ's Video rents games for $8 and games for $3 each. Dave's Video World rents machines for $9 and games for $2.50 each. So what are our unknowns? What are we looking for? So we're going to include our let statement. So we can look at this and we say, okay, well, we've got a variable of $3 each, and how much we pay is our other variable, is our dependent variable. So we can see that x is going to be the number of games and y is going to be the cost. So part A, write a linear equation to represent the total cost. So this is telling us that's going to be our dependent variable of renting a game machine and some games. So we don't know how many games. So that's again why we've used X as the number of games. So if we look back at this, we're looking at the first sentence. 8 is constant. 3 is going to be times the number of games that we rent. So we can see that our equation will be y equals 3x plus 8. Part B, write a linear equation to represent the total cost of renting a game machine and some games from Dave's World. So try that. And now hopefully you came up with y equals 250x plus 9. So now what we have to do is now we have to graph these lines onto a grid. So first thing, we were going to find our point of intersection. We have to think about possible values for our variables. This is where we have to think of our scale. So I'm going to put a break on my scale because I'm already starting up at 8 and I have a slope of 2.5 and 3 and I won't necessarily see it on my grid. So if I put a break on, I can now start my graph. So I'm going to do that and I'm going to put my first graph. This is going to be the point 8. Alright, so we've done a break and we've skipped about 5 or 6 grids. Actually 7 grids. So this is 7 and then 8. Okay, so now we've gone up 3 and now I'm going to go over 1 being a full grid, a full 2 grids over. Right, so we have up 8 and then we went up 3 right 1, up 3 right 1, up 3 right 1. Our other line graphs up at 9 and we went up 2.5 over 1, up 2.5 over 1. Okay, so it's kind of difficult to see where our point of intersection is, isn't it? But what we'll find actually is that for the cost of renting 2 games, we'll have the same point of intersection. So what that means is for 2 games, it costs $14 at both locations. Because if we go back to our equations, 2 times 250 gives us $5 plus 9, and 2 times 3 gives us 6 plus 8 gives us 14. So you can notice that by looking at our graphs, it's not as easy to clearly see it because of the grid lines and the decimal values. So what we'll start to use is we're going to start using algebraic methods to actually narrow it down and get the values faster. We're going to do that over the next few days.